Alright, in this part we are going to look into the reactions of amines, okay, and we can see here we have about two reactions of amines and then two reactions for phenylamines, okay. So basically the reactions of amines is quite straightforward. You are just going to react the amines with the acid, okay. Basically the aliphatic and also aromatic amines, okay, will react with the acid, okay, normally a dilute mineral acid, to produce a crystalline salt, okay, and this crystalline salt can convert back or revert back to the amines, okay. So first thing first, you have your amines here, react with the hydrochloric acid to produce the salt, okay, and this salt can revert back to the amines by reacting it with sodium hydroxide, okay. So this conversion you can look into the subsection of the basic properties of amines, okay. So next will be the reaction of amine with the nitrous acid. But first of all, you should know how to produce a nitrous acid. So nitrous acid is being produced via the reactions between sodium nitrite, okay, not nitrate, nitrite, okay, with hydrochloric acid, okay, to produce your nitrous acid and also sodium chloride. Okay, why? Because this nitrous acid, you cannot keep it in a reagent bottle, so you have to prepare it fresh, okay, with this reaction, okay. And the amines react with the nitrous acid to form alcohol, nitrogen gas, and also water molecule. So depending of the number of branch of the amines, you are going to get a corresponding alcohol. For example, if you use ethanamine, you get ethanol. If you get methanamine, you got methanol, and so on, okay. So in practice, normally you have other byproducts such as ethene and also diethyl ether, but theoretically you just remember these reactions, okay. You have two reactions. One is the production of nitrous acid, okay, through the reaction between sodium nitrite and also hydrochloric acid, and then the reactions between nitrous acid and also amines to produce your alcohol, nitrogen gas, and also water molecule. So that is about the reactions of the amines. So if you look into the reactions of the phenylamines, it's somehow similar for the first part, whereby you are going to divide it into two components, which is the reactions on the side, I mean the branch here, which is the amine branch, okay, and also reaction on the benzene ring itself, okay. So for the reaction on the branch here, the amine branch, similar to your aliphatic amines, you are going to react with the hydrochloric acid to form the salt. One thing to note here, this is NH2, so you are going to form NH3 plus and Cl minus, okay, not like ammonia, where you are going to, for example, NH3 plus HCl, you are going to form NH4 and Cl. So normally you get confused, I mean student will get confused and write NH4 here rather than NH3, okay. So always look into your reactant, what is the number of hydrogen there, and then write the corresponding number of hydrogen for your product, okay. So that is a reaction on the side, I mean the amine group of the chain there, the side chain then, okay. And the another reaction is the reactions on the benzene ring itself, okay. So this NH group here makes benzene much more reactive, okay. So make it more reactive means a more vulnerable for reaction, okay. For example, in this case, phenylamine can react with the bromine, okay. So phenylamine can react with the bromine to produce a 2,4,6 tribromo-phenylamine, okay, which can seen as a white precipitate. So this is actually one of the chemical tests that you can use to test the presence of phenylamine, okay. And bromine is decolorized, means your brown color, okay, reddish brown color is decolorizes. So at the end you'll get a white film of HBr and also the white precipitate of your 2,4,6 tribromo-phenylamine. So always remember here, you need a 3 molecule of your bromine, not one, to produce a 3 molecule of HBr, because you need 3 bromine to be attached to the cycle, I mean the benzene ring itself, okay. So that's about your reactions of phenylamine.